Hi friends, welcome back to Punsirol Science. If you are visiting this channel for the first time, please subscribe and press the bell icon. Today I am going to explain you about Ohm's law. This tutorial will cover basic components of electric circuit, statement of Ohm's law, graphical interpretation of Ohm's law, definition of 1 ohm resistance, determination of resistance from current and voltage graph, using Ohm's law to determine unknown resistance, difference between ohmic and non-ohmic devices, significance of Ohm's law, finally do-it-yourself problems on Ohm's law. These are the basic components and their symbols which are used quite often in electric circuits. First one is cell. It is the symbol for dry cell that you have seen very often in your daily life. Battery is nothing but it is a series combination of 2 or more cells. Third one is the adjustable battery. Fourth one is switch. Fifth one is the voltmeter. Next is the ammeter. That last one is the variable resistor. Now let's go to Ohm's law. Who discovered Ohm's law? Georg Simon Ohm, German physicist and mathematician, discovered Ohm's law based on his experimental studies on current electricity. Ohm's law states that current passing through a conductor is directly proportional to the potential difference across the conductor. Current is directly proportional to the potential difference, and if M is the constant of proportionality, we can write I equal to M multiplied by V. From here, you can obtain this relationship 1 upon M equal to V upon R. And V upon I is always constant for a conductor, and 1 upon M is known as resistance of the conductor. This is the graphical interpretation of Ohm's law, and as I have told you earlier, V upon I is equal to a constant, and since the graph is a straight line, we can represent these straight lines by the equation y equal to mx plus c. The graphs are passing through the origin, so this c will become 0. Finally, I can transform this equation in the form of I equal to mv, where m is the slope of the graph. The slope of the graph changes with temperature and type of the material of the conductor. Now let us see how you can find resistance of a conductor from its current versus voltage graph, and this red colored dotted line represents current versus voltage graph of a conductor. In this figure, the linear graph is inclined at an angle of theta with respect to x-axis. From y equal to mx plus c, you can get I equal to mv. M is the slope of the graph, and this slope is given by tan theta. And tan theta is given by OA upon OC, and OA is current along y-axis, OC is the voltage along x-axis, and the resistance is given by 1 upon tan theta, and this is nothing but 1 upon slope. So this means that higher the slope, lesser is the resistance of a conductor, and this topic is very important for class 12 science. So once you have understood this basic concept, you can easily find out the resistance of a conductor if its IV graph and its inclination theta is already known to you. Now let us see how you can define 1 ohm resistance from Ohm's law. In the equation R equal to V by I, the resistance R is equal to 1 ohm when you put V equal to 1 and I equal to 1. Therefore, 1 ohm is the resistance of a conductor that allows 1 ampere of current to flow through it when the potential difference of 1 volt is maintained across the conductor. You can determine resistance of an unknown ohmic conductor by using Ohm's law based on this simple experiment. In this circuit, a battery, a known resistance, and unknown resistance, they are connected in series. An ammeter is connected to measure current passing through the loop, and a voltmeter is connected to measure the potential difference. Remember, this known resistance is connected for some reason. It will try to prevent accidental short circuit condition in between positive and negative terminal of the battery. At the same time, it will try to limit the flow of current in the circuit. In the left hand side, I have prepared an experimental table. The first column represents serial number. Second column represents applied voltage. Third column represents current passing through the conductor. And the fourth column represents potential difference across the unknown conductor. Initially, you will set the voltage to 0. Then you will slightly increase to 1 volt, 2 volt, 3 volt, 4 volt, and so on. That is why in the circuit, the battery has been made adjustable, and this is the symbol for adjustable battery. Alright, now let us see what about this -3, -2 and a -1. So in order to get this reading, you are going to change the polarity of the battery connected in the circuit. So for this minus voltage, you will get minus current and a minus voltage. Finally, you will plot a graph. From the Ix and the Vx graph, the reciprocal of the slope will give resistance of the unknown ohmic conductor. Alright, this figure is illustrating the difference between ohmic and the non-ohmic components. In case of ohmic, the graph should be a straight line, should always pass through the origin of the xy plane. And if it is non-ohmic, the graph will no longer be a straight line. Metals, metallic alloys and resistors are example of ohmic component, whereas semiconductor and semiconductor devices are example of non-ohmic components. Now an important question is the relation resistance equal to voltage upon I still useful for non-ohmic electrical and electronic devices? The answer is yes. R equal to V upon I is still used in circuit analysis of non-ohmic devices. However, their resistance depends on their operating voltages and current in the circuit. Now, what are the significances of Ohm's law? Ratio of voltage to current gives resistance of a conductor. The resistance remains unchanged for any applied voltage. For ohmic conductor, magnitude of electric current is independent of the polarity of the applied voltage. Ohmic devices are known as bidirectional or bilateral circuit components. These devices will carry the same amount of current even when you change the polarity of the battery, so they are known as bidirectional or bilateral circuit components. These are some of the basic formulas which will be necessary for solving problems in electricity. From Ohm's law, V equal to II. From this relationship, you can obtain I equal to V by R or R equal to V upon I. And electrical power is given by P equal to VI. And by using Ohm's law in P equal to VI, you can obtain P equal to V square upon R or P equal to I square R. As you know already, electric charge Q is given by product of current and the time. Then this relationship can be used in the next line. Work done is given by power into time, and work done is also given by voltage into charge. And if you put the value of Q equal to IT, the work done is again given by I square RT. Here I have given you a simple technique by which you can remember 4 basic formulas very easily. So if you remember these diagrams and phrases, it will be easier for you to remember this formula. Now I am coming to the do-it-yourself questions. So the first question is calculate resistance of a resistor if it draws 0.5 ampere of current from a 5 volt battery. Second question, calculate current passing through 100 ohm resistor if there is a potential difference of 10 volt across its two terminal. 2 ampere of current passes through a 50 ohm resistor for 60 seconds. If the battery voltage is 10 volt, calculate power delivered by the battery, work done by the battery, amount of charge transferred. Do these IV graphs represent metals? Give your comment. What is the resistance of a conductor if its IV graph is obtained as shown below? Here the angle of inclination is 45 degree. Obtain the mathematical equation of current passing through a cylindrical conductor. If its length is increased by 50% while the cross-sectional area is reduced by 50%, assume that potential difference of the conductor remains unchanged. IV graph is given here for two metals, metal A and metal B, and you are going to find out which metal is having higher resistance based on the slope of the graph. Okay, assume that a conductor has got two different IV graphs at two different temperature level. Identify the graph for lower temperature.